Now that we've gone over some of the basics of exponents and what they are, what they mean, we are going to look at some specific rules or properties of exponents and some shortcuts that we can use to help us with those. So the first one we're going to look at is the product rule. And if I have a problem like 2 to the third times 2 to the second, well, let's first expand it out. So like it says here, when in doubt, stretch it out. We're going to look at shortcuts, but that doesn't mean you have to use a shortcut. Or if you forget what the shortcut is, we can stretch it out. So what that means is I'm going to take this 2 to the third. Well, that means I've got 3 2's. And then I'm going to multiply that by 2 to the second. That means I have 2 2's. If I think of this as one big problem now, what do I have all together? I've got 1, 2, 3, 4, 5 2's. So 2 to the fifth. And then we look at the beginning. How can I go from here to here? And I should notice that if I take 3 plus 2, I get the exponent of 5. So the shortcut is to add the exponents. So if we're multiplying, like we were here, we're going to add the exponents. A quotient rule, when we are dividing, we can do the same thing. We can expand it out. So I've got a fraction bar, so I'm going to put a fraction bar. On the top of that fraction, I've got 2 to the fifth, so 5 2's. 1, 2, 3, 4, 5. And on the bottom of that fraction, I have 2 to the second, or 2 2's. And what we're going to do here is we say cancel out, but what we really mean is, for example, if I have 2 divided by 2, that's 1. So anytime I have a number divided by itself, it's 1. So 2 divided by 2 is 1. 2 divided by 2 is 1. And if I multiply anything by 1, multiplying by 1 doesn't change it. So we can just ignore those ones. That's why we say they cancel out. And we want to see, well, what do we have left over? I have 2 to the third. And in the numerator, I've got nothing left in the denominator. So I don't really need. I could put over a fraction bar, and I could say this was a 1 and a 1. 1 times 1 is 1. But really, that's just the same thing as saying 2 to the third. Because dividing by 1 is not going to change my answer. Okay, so how can we do a shortcut with this? So how can I go from where I started to where my answer was? And maybe we notice that if I take our exponents 5 minus 2, we get 3. So we're going to subtract the exponents. So when we're doing the product rule, when we're multiplying, we're going to add the exponents. Quotient rule, that's when we're dividing. We're going to subtract. And one way to remember is multiplying makes something bigger, adding makes something bigger, dividing makes something smaller, subtracting makes something smaller. That might help remember that. And then we have the power rule. And that means we have 1 raised to another. So first let's expand this out. This means I have 2 to the second 3 times. So I have 2 to the second times another 2 to the second times another 2 to the second. And then each of these I can expand out. 2 to the second means 2 times 2. And then I'm just going to bring down this multiplication sign. And then 2 to the second means 2 times 2. Then I'll bring down the next multiplication sign. And the last 2 to the second means 2 times 2. So we think of this all as one big long problem. See, what do we have? We've got 1, 2, 3, 4, 5, 6. So 2 to the sixth. And again, we want to look for a shortcut. How do I go from where I started to where I ended up? And we might notice that if I take 2 times 3, we get 6. So on this one, we're going to multiply the exponents. And we have to keep in mind that in a lot of problems, we're not necessarily going to see these individual properties by themselves. But we're going to get to bigger problems where you might see a product rule where we have to add the exponents combined with a quotient rule where we have to divide, where we have to subtract the exponents. Or it might even combine these with the previous rules, like an exponent of a 0 or a negative exponent. So we could see multiple of these mixed together. This is just a start. And when we look at some examples in the next video, we can kind of see how these pieces all fit together.